Kia ora and welcome to question 4 of the 2010 Scholl Calc exam. This question is pretty much all conics. As I've said in previous videos, conics used to be an external assessment, so there used to be quite a bit of conics in scholarship. So part A here is looking at parabolas that meet at single points or with a common tangent line. Part B is looking at finding the length of a tangent line to a circle. And part C is quite tricky. It involves a parabola there and two tangents, of which we need to find a locus for the point of intersection. Okay, part A. We've got these parabolas, x minus a squared, x plus a squared, and we're told that b is a number between 0 and 1, but we're not told whether a is positive or negative. It doesn't really matter, but if a was positive, then the right parabola is x minus a all squared, and the left parabola is x plus a all squared, and then the one in the middle is the one that's been shifted down by k, bx squared minus k, where b is a positive number, so therefore it's opening upwards, and k must be a positive number as well because it looks like it's been shifted downwards. So this position here is minus k. Alrighty, find k in terms of a and b. So the only information we know is that these parabolas meet with a common tangent line there. So if we solve the parabola here, bx squared minus k, simultaneously with one of the other ones, let's just pick this one, no reason why, but let's pick those two. If we solve that simultaneously, then the discriminant must equal 0. Okay, I don't need to use any differentiation for this, even though it's talking about tangents. I just solve this equation, x minus a all squared equals to bx squared minus k, and the solutions to this equation are values of x that represent the points of intersection. Expand that out and put it into a standard format. We've got 1 minus b all times x squared minus 2ax is the linear term, and then a squared plus k is our constant term, and then go straight to the discriminant. Be careful with this because there's a's and b's in the quadratic, so I like to put inverted commas around this, like a and b doesn't mean a and b from the problem. It means this dude here is a, that dude there is my b, and that there is my c. Okay, b squared minus 4ac, so minus 2a all squared minus 4 lots of 1 minus b times a squared plus k, and that equals 0 for one solution or for a tangent. Okay, expanding that out, we've got 4a squared minus 4 lots of a squared minus ba squared plus k minus bk. And at this point in the exam, I'm thinking about bk. For those who are watching that are outside of knowing what Burger King is, that's what I meant. The 4a squared terms cancel. We've got a ba squared. No, we don't. We have a 4ba squared. I've got minus 4 on the outside of the brackets. Minus 4k and a plus 4bk equals 0. And I need to make k the subject. The question said find k in terms of a and b. So the terms that have got k's in them, I leave them on one side and I factor out the k. So I've got k times 4b minus 4, and the other term, 4ba squared, can go to the right hand side, and then I divide through by 4b minus 4, and I can tidy this up a little bit by dividing top and bottom by minus 4. That will leave us with ba squared. It will leave the bottom as 1 minus b. Okay, and that's pretty tidy. I don't think I can do any more simplifying of that. Alrighty, we could think about whether it actually makes sense in the context. Remember I said at the outset that k needed to be a negative number to match the picture that was given to us. We're told that b is a number between 0 and 1, which means our denominator there needs to be greater than 0, and the numerator there would be positive as well, so k is a positive number, which makes sense. Okay, question part B. Prove that the length L of a tangent line from an external point PQ to the circle x squared plus y squared plus 2gx plus 2fy plus c equals 0. That looks really messy, but the 2g and the 2f help us algebraically because we can complete the square nicer. So we need to first up think about what that circle would look like, and then an external point PQ, so the point that's off the circle, we need to find the distance between that point and the circle. Okay, so draw a diagram to support your answer. We'll start with a diagram. Equation of the circle was x squared plus y squared plus 2gx plus 2fy plus c equals 0. And we start off by completing the square on this, x plus g all squared, by looking at the x squared and the 2gx term. What I've done there is made it x squared plus 2gx plus a g squared, so I need to take away g squared. Do the same thing with the y terms, y plus f all squared minus f squared, and then the c is a constant. Move the constants all to one side, to the right hand side of the equation. That's going to be related to the radius of the circle. Going to have g squared plus f squared minus c. Now that's in a standard format for a circle. You know, the format I'm talking about is usually written like this, where the centre is AB, the radius r. So for this particular circle, the centre is negative g, negative f, and the radius is equal to the square root of g squared plus f squared minus c. So we could draw the circle. Let's assume that g and f are positive, although it doesn't matter. There's no loss of generality if we do that, but let's do that. So therefore minus g is here and minus f is, say, down there, and we don't know how big g and f are or how c is, so I mean, we could have our circle. Let's actually can I create a circle? Oh, this is going to be an interesting one. Is it going to work for me? Oh, how good. Alrighty, so our circle could look something like that, where let's go this radius here, g squared plus f squared minus c square rooted, and we're told there's some external point. So I don't know, let's make the external point somewhere over here. No, that's on the axis, I don't want to do that. Let's put it there. So this external point was given coordinates PQ in the question. And we need to prove that the length of a tangent line, apologies, when I read that earlier, I think I said distance from the circle, which would be a little bit trickier because there'd be different points on the circle, so the distance would depend on what point you're talking about. And if we were talking about the distance to a circle, it would mean the perpendicular distance. We'd need a tangent there, and then we would be finding the normal to that tangent, a line that's right angles, and finding the distance between. But that's not what the question's asking us to do. If we have some line here which is a tangent, we need to find its length. In other words, the distance here, L, goes from PQ to this point that's a tangent. Now you don't need to use calculus in this question to find the equation of the tangent. All you need to realize is a little bit of geometry here, that this doesn't really look like it, but it's a right angle. A tangent to a circle makes a right angle with the radius. And we also know this length because that length, which is the hypotenuse of that right angle triangle, is simply the distance between 2 points. The point negative G, negative F, the centre, and the point PQ. So Pythagoras tells us that L squared is going to be equal to the radius, the hypotenuse squared minus the radius squared. Okay, and what is that hypotenuse? The distance between 2 points. We need to take the difference in the x values, square them, the difference in the y values, square them, add them up, square root. In other words, it's another Pythagoras, isn't it? It's like making a right angle triangle there and finding the difference between, no, not that way, straight down like that, where there's the change in y, there's the change in x, and then using Pythagoras on that. In other words, the distance formula. So, the change in x is p plus g. Be real careful there. It's this distance here is p, and this distance here is g. So it's p plus g, or p minus g, all squared. And then the change in y similarly is q plus f, all squared. And that's the distance squared. So I could put the square root in it, but then I'd have to square it again. Minus the radius squared. What was the radius squared? It's g squared plus f squared minus c. The radius was the square root of that, but I'm squaring it. It's my length squared. Let's expand that out and tidy it up a little bit. P squared plus 2pg plus g squared plus q squared plus 2fq plus f squared minus g squared minus f squared plus c. Okay, the g squareds cancel. No, they don't. One of them cancels. The f squareds, why have I got two? Ooh, because my g now looks, my q became a g. What a gangster. Delete the f squareds, and we're square rooting that. The length is equal to the square root p squared plus 2pg plus q squared plus 2fq plus c. And I believe that's the answer. P squared, q squared, 2gp, 2fq, and a c. Perfect. Alrighty, last question, as I said from the outset, is pretty evil. It's fairly systematic, the algebra blows up. Okay, the first thing is we've got the difference between the x coordinates of 2 points on the parabola is fixed at 2k, fixed meaning a constant. And that's, if we've got this point here on the parabola and another point on the parabola, we can see that the distance in the difference in the x coordinates is 2k. Where k is some constant, find an equation that describes the position xp, yp of the point of intersection. So this point here, which has been given coordinates xp, yp. So the first thing, I guess, to point out is that those 2 points, we don't know where they are. All we know is that they're on the equation y squared equals 4ax. So first thing I'm going to do is call them, I could call them xa, ya and xb, yb. But it turns out I don't need both of those. So I could say let the leftmost point be xa, ya, and the rightmost point is going to have an x value that's related to the x value of a. It's going to be xa plus 2k, and then the y value, I'm going to call it yb at the moment, but because those points are on the parabola, the x and the y values are related by the parabolic equation. So we know y squared equals 4ax. So to find the y value of a, we just substitute xa into that formula and square root. So ya is equal to the square root of 4a xa. The subscript notation is going to get confusing because there's an a in the parabola equation. Maybe I'll change to capital. Okay, that makes it a little bit clearer. Yeah, and of course I could square root that 4 if I wanted to 2, but that's the only thing that would tidy up. We also know that the yb value is the square root of 4a times by xa plus 2k. And so I've got my coordinates. Now going back to this picture, how's that helped? We now need to find the equations of the tangents so that we can find out where they meet. And for that, I'm actually going to use differentiation. Unlike the previous question on tangents where I just used the discriminant, I'll find the equations of those lines and then solve them simultaneously. So the tangent at xa, ya, I need to find its slope, so I'm going to use differentiation to find the gradient function of the parabola. Y squared is equal to 4ax, 2y dy dx equals 4a. It's implicit differentiation. Dy dx equals 4a over 2y, where y is a point on the parabola, so it equals to 2a over y. Now, the equation of a tangent is just a straight line, so I can use the y minus y1 equals m times x minus x1 formula. The y value, the specific point is ya, but I know that ya is the square root of 4a xa equals the slope 2a over the square root of 4a xa all times x minus xa. So that's one tangent. The other tangent follows a similar format. xb, yb, y minus the y value at b, which we found was this, equals the slope at that point, which is exactly the same gradient equation, it's just a different value of y in there. X minus xb, where xb was xa plus 2k. Alrighty, so systematic so far. We're just finding equations of tangents in terms of the points that are moving, the xa point and the xb point. But as soon as xa moves, the leftmost coordinate moves, the rightmost coordinate's dependent on it because the x values differ by 2k. So the only variable that's in here is xa. That's the only thing that's changing. A is a constant, it's related to the shape of the parabola, and k is a constant, it's related to that difference between the x values of the coordinates we're using. Okay, now once we're there, we need to find a point of intersection. Okay, so to find the points of intersection, we're going to solve this simultaneously. And I think we need to be clever about how we do that, because otherwise it's going to blow up. If I multiply that first equation through by the fraction's denominator, root 4a xa, so I'm going to have square root 4a xa times y minus 4a xa, because the square roots will cancel, equals 2a x minus xa. And I do the same thing for the other one. just tidy it up a little bit. Root 4a xa plus 2k times y minus 4a xa plus 2k equals 2a minus xa plus 2k. Okay, what are we going to do here? We need to find the points of intersection. There are two straight lines that we're solving simultaneously. We could solve for x or we could solve for y first. Do we have any other extra information in the question before I do that? No, it's not like the tangents are at right angles or anything. Find an equation that describes the position of the point of intersection. Alrighty. Wish me luck. Okay, solving this simultaneously. Let's make y the subject of both of these equations. It's going to bring the fraction back in though. Do I want to do that? Why not? Y equals 2a x minus xa. My handwriting's just got darker. I'm a little bit nervous of where this is going. Plus 4a xa all over square root 4a xa. Does this tidy up? I think it does because there's some like terms in the numerator. There's a 4a xa there, and inside there there's a minus 2a xa. So we've got 2ax plus 2a xa, and even that factors 2a x plus xa. Okay, so that's the y value on the first tangent in terms of its x position. Do the same thing for the other one. Move the 4a xa plus 2k term, this term here, move that to the other side of the equation. This would definitely be one of the top scholar questions in this year's exam. Divide by that square root. Does that simplify at all? Are there any like terms? There's a 2ax in the numerator. There's a minus 2axa with a 4axa, so we've got the same thing as what we had in the first expression. And we've got a minus 4ak with an 8ak, so that's a 4ak. And then factor out the 2a again, x plus xa plus 2k. I could have predicted that was going to happen. Oh my goodness, why? I just repeated myself basically, because at this point, see how the structure's the same? That's x plus xa, that's x plus xa plus the extra 2k. The 2a's in the front, and instead of xa down the bottom, it's xa plus 2k, because the only thing that changed was the x coordinate. Okay, so it looks like I'm on the right track. Now if I solve those equal to one another, solving simultaneously, we can equate the two expressions. This is just to find the x value of p. Cross the 2a's off. Do I want to cross multiply? Yep, I'll cross multiply the thing. Now, I'll square both sides to get rid of the square root. When I square the left-hand side, it's a product, so it's something like it's like this thing here times that thing there. When I square it, I'm going to square both those things. So I get rid of the square root for the first term. Then I get x plus xa all squared. This one here, x plus xa plus 2k all squared, yippee, times 4axa. Now I can get rid of the 4a term. And do I have anything else I can get rid of? No. xa plus 2k, it's not a common factor on that side, times by x squared plus 2xxa plus xa all squared. Now, to expand this trinomial, I'm going to group these dudes together. So I'm going to get x squared plus 2 lots of x times xa plus 2k plus xa plus 2k all squared. And then I'll expand the extra brackets I've just created. And that's all times by xa. Okay. Remember that xa was my only variable in this, so I need to get x in terms of xa out of this equation. I could just expand the whole thing and see what I get. I can see that there's going to be some terms that cancel. For example, this first term here, xa x squared, is actually sitting there as well, so they're going to cross off both sides. I just don't want to do this in my head because I don't trust my algebra under pressure. Let's just write all the terms out. Okay, so that's the left-hand side. Just checking, got xa x squared, got xa times 2x xa. Oh, where's that one? Xa all squared times 2x. Where did my 4x come from? Good thing I checked. And this term here, xa all cubed is that one. And then 2kx squared is that one. 4kx xa is that one. And 2kxa squared is that one. Alrighty. Now right hand side's even worse. Equals x squared xa. That was a nice term. Plus 2x xa squared, because there's another xa at the end of the brackets. Plus 4xk xa plus xa squared times xa, so cubed, plus xa times 2k times 2, so 4k xa all squared times xa, so another xa cubed. No, just squared. And then 4k squared times xa. Alrighty, what terms cancel? Xa times x squared. We've got xa cubed and an xa cubed. We've got a 4k xxa. And then we've got a few like terms as well, but I don't think anything else cancels. Oh, yep, 2x xa squared. Alrighty. So what was our goal? We were trying to make x the subject of this because the x value will be the x value of p, xp, the point of intersection. I'm also going to divide everything through by 2k. So x squared plus xa all squared equals 2xa all squared plus 2k xa. Moving stuff around. Okay, so this tells us that our x value of p is the square root of xa times xa plus 2k. To find the y value of p, we just need to use one of the tangent equations. So I could go up to the This equation here, copy that down. Okay, that's my equation of one of the tangents. So I'll use that one to find my yp. 2a multiplied by x plus xa. Remember that x is some position on the tangent, and I'm looking at the specific point P now, xp. So I've got 2a multiplied by this dude plus xa, all divided by root 4a times xa. And somehow I need to find a way of relating these equations together to find out how the locus of this point. Is it on a circle? Is it on another straight line? What's its equation? And so what I'm going to do first is square both of these, because at least that gets rid of the square root, and I need to find a way of connecting the two. So it's xp all squared. I already had that in the line above. And then yp all squared, 4a squared times the whole bracket at the top squared. This is an absolute nightmare. All divided by 4axa. And the variable in this problem, remember, is xa. I need to get rid of that somehow. And how am I going to do that? Really nasty. Okay, I can get rid of the 4a there. And get rid of one of the a's in the 4. And I can also divide everything in that bracket by xa. Xa's gone there, xa's gone there, and xa's gone off that one. So we're left with a multiplied by xa plus 2k plus 2 lots of this dude plus xa, all divided by, no, I've got rid of the xa's as well, so it's gone. That's yp all squared. Now at this point, like, if I want to find its equation, I can drop the yp and the xp sort of notation. But I need to find a way of putting this xp into the equation. And can you see that xa times xa plus 2k is this dude here, so that's xp all squared. So I can square root that. And it gives me 2 times xp. But I still need to eliminate this xa thing and put it in terms of xp. And the only way I can do that is to go back to this problem here and solve a quadratic equation. So I have xa all squared plus 2k xa minus xp all squared equals 0. I can complete the square on this. Plus or minus, but we're going to take the positive root there, and then I've got xa is equal to minus k plus, think about why I took the positive root. So that there is my x value, a, which is my variable in terms of xp. Now I can dump that into this yp equation down here. Yp squared is equal to a xa plus 2k. Well, xa plus k is this dude, so I need to add another k to that. Root k squared plus xp all squared plus another k plus 2xp plus xa, which is minus k, plus this dude. That's quite nice because the k's cancel and there's 2 of the square root, so I can factor out a 2. Okay, and like I said, drop the notation now. So it looks like it's a parabola, but we'll have a look at what it looks like in a sec on GeoGebra. No, it's not going to be a parabola, I don't think, because of it's kind of the starting of a parabola, y squared equals something, but alrighty, so is that the answer to the question? Well, let's have a look on GeoGebra. We've got the parabola in there, y squared equals 4ax, in this case a is 1. I've put some random point on the parabola and that point moves. The vertical line that I've got in there is a distance of 2k away in the x direction. And then once I define that point, I found its point of intersection on the parabola. That's my yb value from earlier. Now I've found the tangents, the equations of the tangents at both of those points, point A and point B, and its intersection, point C. And I've turned the trace on to C, so when I move the point A, C moves and it keeps a copy of where it was previously. And the green equation is the equation that we came to at the final step. And it's not a parabola, as I was saying, it kind of looked like one to begin with, but it's actually a pretty random curve that almost looks like a parabola for large values of x, hence the inequality that we proved at the end. Okay, so if I move the point A just to confirm, it stays on that green curve, which means that our locus is correct. There's a bit of a problem on this other side here, because we only considered positive x values, of course, because the parabola is only defined for them, but we didn't consider the y values being negative, but we squared the y value anyways, so it wasn't an issue. Finally, we need to prove, because there's a second part to this question if it wasn't hard enough already. My goodness, where is it? Write your answer into the form yp squared equals some function of xp. Well, that would have been helpful. I was trying to find a way of connecting that together, and hey, it actually told us we should square the yp. Fortunately, I did that. And show that the equation is squashed in between 4axp and 4axp plus 2ak. Well, this yp squared thing has to be bigger than 4axp, because that would be, if we consider like a position xp somewhere, then the value on the parabola would be equal to 4axp. No, would it? Square rooted. So the yp value squared must be greater than the square of that. So the lower bound kind of makes sense. But let's prove this upper bound. Okay, so to do that, we just need a little bit of inequality logic here. So this is definitely true. Let's see. But what about the, no, that's yp squared, and this is technically 4axp. But then what about that upper limit? So it's kind of sneaky, but if we, underneath the square root, a bit of trickery here, and we turn it into a perfect square by adding an extra term in. Okay, that term's positive, k is positive, and we're talking about x being on the right hand side, so positive, so that's clearly bigger, and now it's a perfect square. Go over here, so that's equal to 2a multiplied by square root of x plus k all squared. And that there is 2a multiplied by x plus k plus x, which is 2a, 2x plus k, which is 4ax plus 2ak. And again, that's the, putting the xp and the yp back into that would be 4axp plus 2ak. Okay, so that's proven that yp squared is sandwiched between 4axp and 4axp plus an extra 2ak. Wowee, what a difficult problem. Catch you in the next one for question 5.